Do any of you live somewhere where you got a whole bunch of snow?
Yes.
How
The
about you,
university
Krista?
campus got closed today. And the campus is barely ever closed. So,
Yeah, we got like 16 inches yesterday, so
Wow.
we're digging out.
not that bad. But like we have been getting snow one after the other.
Yeah.
It's just been. Hi, Dipankar.
Hi, greetings, Simar. Hi, Andrew.
Hello,
Hi,
hello.
Chris.
Hi, Dipankar.
Right, Andrew, do you want to take over? Make the
Sure.
introductions?
Yeah, I guess I'll share my screen and maybe we can start with some introductions. Hi, my name is Andrew. Thank you, Susan. Nice to virtually meet you. We're all in our own, I guess, home offices today because the university is closed down, but I guess we'll admit Caitlin too. I'm a faculty member in the Mechanical and Mechatronics Engineering Department at the University of Waterloo. I worked with the Ideas Clinic for the better part of the past 5 or 6 years, kind of co-developing a lot of all of this content and offering it to undergraduate and graduate students. So I'm excited to kind of share this engineering simulation master's degree with the group here. It's been a labor of love. I'm glad Caitlin can join. I know Janos is a recently new father, so that's good news that he's taking some time off. But yeah, I'll hand it off to whoever wants to introduce himself next.
Samir and Chris, you're also known to me, but not so much perhaps to the others. Would you go next?
Sure. Simar, go ahead.
Sure. Hi, Susan. I think so. My name is Simarjeet. I'm a faculty member in Electrical and Computer Engineering in University of Waterloo, and I'm also the directors of Ideas Clinic. Ideas Clinic is an experiential learning center. I think Andrew's like if you look at the right-hand picture, that is the one of the clinic facilities we have. So we uh, basically run any experiential learning, both curricular and co-curricular. So we work with profs in various departments and try to develop hands-on activities for their courses. We also run lots of after hours, weekend events where we uh, we try to develop various things, right? So with Ansys, we have been working with developing finite element workshops to teach students how to do simulations effectively. Chris, do you want to go ahead?
Sure. Hi, I'm Chris Rennick. I'm an engineering educational developer with the Ideas Clinic. And I've been with the Ideas Clinic for more than 10 years at this point, back from when the original agreement with Ansys and Sanjeev with his design chair sort of formed. So I've been working alongside you folks for a long time. I guess, aside from the sort of curricular and co-curricular workshop things that we run, the other aspect of this relationship that I take care of is the capstone design analysis competition that'll be running just in about a month or two from now. Yeah, happy to be part of the call and nice to see you again, Dipankar. It's been a little while. Yeah.
Yeah, it has. It has. Susan and Caitlin, if I just jump in briefly, although all three of our colleagues from Waterloo know me, but just to clarify that I've been involved almost from the get-go, I would say, right, Chris and Andrew, in the UW relationship, and particularly with the Ideas Clinic. It goes without saying that we've had this very long-standing connection with the university. Obviously, it's a premier institution worldwide and in Canada. And given the proximity of our offices in Waterloo itself and the strong connection between the various technical communities at Ansys and Waterloo in the past and going forward, it's been super important. But I got involved in supporting the Ideas Clinic mostly in the early days, Susan and Caitlin, through the Discovery Project, and supporting the idea that this tool could be supporting our flagships in terms of education, design, And obviously, Andrew, Chris, and others led the charge, but we've been in supporting mode. Also for providing some seed funding over the last, I would say, 4 or 5 years, over the tenure of the agreement to get some of this work started off. So that's been my involvement. And Chris, Simar, and Andrew, I should make note of the fact that Susan has taken charge of our overall academic program, a kind of an anchor role that I kind of tried to play in the past. It's not that I'm disappearing from the academic program, but my focus is mainly going to be supporting on the technical side and on the education side. So I just want to take that opportunity to say this is a little bit of a changing of the guard, if I might say so. Susan, do you want to take over?
Susan Coleman, I've been at Ansys now, part of Synopsys, almost 10 years, and I've been working with Dipankar and other people across the company for the entirety of that on academic and startup. So it's not like anything in this space is new to me. I work out of our strategy and corporate development function of the company. So prior to this kind of shift with Dipankar's role, I was working very closely with him on a lot of the program management side of things, our product offerings for academic and how we price those and take them to market, the marketing and partnership side of things as well. So yeah, I mean, although I'm not familiar with this specific engagement, I'm very familiar with our overall academic strategy. And so this shouldn't be, a big change for you guys at all. But very nice to meet you all.
Yeah. And Andrew and Chris, just to clarify that the team that used to report to me, so Janusz and Caitlin and others, they're part of Susan's team now. So I have the luxurious position of not having any reports now. So.
Well, on that note, as a past Dipankar, now Susan report, I'll quick introduce myself. My name's Caitlin Tyler. I've been working at Ansys for now part of Synopsys for 7 years now. My entire time has been focused on academic in various roles, but specifically I've been working with Andrew for, I want to say it's been like a year or two now that we've been having those meetings, Andrew, to help turn the content from the workshops into what we call our Ansys educational resources, so that others are able to see what you've all been doing and try to implement it in their curriculum as well.
Well, thank you all for that intro round, and thank you, Dipankar, for describing the changing the guard. I think we're in great hands with Susan. So is there anything we want to kind of discuss before I bring up the presentation here on the graduate diploma? Cool. Okay, I guess I'll get started. I know some of the language the university uses. The word GDip in this case is a graduate diploma in engineering simulation, but it's specifically catered towards Masters of Engineering students. And Susan, I'm excited because I know you were an advocate and kind of let's say, a technical liaison for the University of Madrid's version of this. And I'll kind of talk about how this is an enhancement or a differentiation of that, and some of the benefits of the implementation that we're planning here. You may have seen my screen flicker around a little bit because I was actually grabbing a slide from another presentation to do a little bit of a history lesson here because of what Dipankar mentioned. But here are some of the very early days of prior to Discovery, Ansys AIM, that I think was part of Dipankar's previous kind of brainchild of the design software, design analysis combo software that we did a whole bunch of case studies in, and these were actually hosted on YouTube at the time. This was kind of very early on in the digital asset era of engineering education, but you can see some examples here of a bicycle wheel, a bicycle frame, and an underwater remote operated vehicle that we did simulations on. And this really was coupled with the first time that I guess the Ideas Clinic benefited the undergraduate students at the University of Waterloo with the immersive design experience kind of curriculum pedagogy, in my opinion, because this, I think, was a 4th year project or maybe a 3rd year design project. And then these were actual experiments that we had in class kind of to couple with the simulation, and I'll talk more about that in a little bit. But as far as what we wanted to talk about today, I'll talk briefly about a needs assessment for why a simulation-based master's program is useful. I actually did this presentation to the faculty committee on Friday, so I know it's an easier sell to you folk in terms of why this is a useful thing. But especially in Canada, there is a huge demand to expand Masters of Engineering enrollment and financial sustainability. I think that's worldwide, but the way the funding streams work in Canada, in particular, is a Masters of Engineering student is profitable for the university. So that's one reason why this is really relevant at this moment in time. The second thing is the Ideas Clinic kind of functions as one of the only interdisciplinary links between the departments in the Faculty of Engineering. And this simulation diploma is kind of a pioneering effort, in my opinion, to have graduate programming that is truly interdisciplinary. I think the engineer of 2050 is very different from the engineer of the new millennium in terms of interdisciplinary skills are what are really job requested or relevant in the current job market. So that's one thing this is really useful. Waterloo has an integrated co-op program. You may or may not have known that, Susan, but effectively the students go 4 months school, 4 months of work, 4 months of school throughout the duration of their undergrad. So a 4-year program is actually 5 years long. For Masters of Engineering students, effectively a lot of them are international students that are coming to obtain a degree from the University of Waterloo. And this immersive MEng diploma in simulation is effectively not replacing the entire co-op experience and all the tacit knowledge they would gain from that level of let's say job experience, but it's going to help them kind of supplement it, I would say. So it's enhancing kind of employer engagement as well, because we've done a lot of projects with industrial collaborators, and I think you'll see it through the case studies and the educational assets that Caitlin mentioned, how important that is. Also in Canada, specifically in Ontario, the province that the University of Waterloo resides in, there is continual professional development for licensing to be a professional engineer that a lot of industry partners or let's say industry professionals need to do 30 hours of let's say training to kind of fulfill their requirement to continue as a professional engineer. And the other final thing, which I think is the most important, is differentiating Waterloo and by proxy Ansys Synopsis with cornerstone experiential learning. And often experiential learning was different maybe 20, 30 years ago when it was just hands-on activities, but coupling hands-on activities with kind of a digital twin environment is the real way to leverage this and scale it to an international audience. So I'll talk about kind of how the pedagogy works in a second. But in terms of some of the details here, so I use the word multidisciplinary link, which Ideas Clinic obviously is kind of the foundation of that at the University of Waterloo. This master's in simulation graduate diploma is effectively proposing these 7 or 8 streams here, which are effectively different research specializations, but 2 of them are very traditional simulation topics like structural analysis, fluid mechanics, and fluid dynamics for CFD. And these are near and dear to a lot of your hearts in terms of your research specialization or what your undergrad may have been in many years ago. But we also have developed streams and programming and content and case studies in the electromagnetics and radio frequency side of things, robotics control and automation. We have one in digital twin and simulation driven design, coupling different physics domains together, which often is a very big sticking point in terms of doing this in a educational environment at the university, because they really approach things in a siloed manner. So coupling those physics together in multi-physics problems, and I'll talk about the details of the case studies that we developed. A really hot topic, and there's tons of research facilities here, especially at the University of Waterloo, regarding additive manufacturing, and then looking at some life cycle analysis of like cradle to grave, the recyclability of an additive component, processing and things like that. But even looking through all of that through the lens of sustainability, that's another thing that we've done entire kind of design activities in sustainability initiatives and things like that. So there's more, but these are the streams that we're working on right now. I'm going to use the word asset or educational asset a lot in the rest of this presentation, but we've done a number of, or let's say deployed a number of educational resources thus far. As Chris mentioned, we have a whole bunch of workshops that we've run for several thousand students by now for the past couple of years regarding simulation specifically, and training them from a very beginner level to kind of what we're calling a competent undergraduate student. We have a grad course that I actually developed and offered 5 or 6 times in the past half a decade called Design of a Mechatronics System, which effectively is the model for this graduate program. We also have, with Janos and Caitlin and a number of co-op students, developed a number of case studies and lab manuals for these educational assets to be deployed and effectively converted from simple workshop examples to a full-blown case study. And a lot of these ideas came from industrial collaboration, fourth year design projects. That's what the acronym FYDP stands for. It's very common at the university, so excuse me with some of the jargon here, as well as student teams. I'm actually the faculty advisor for the largest student team on campus, which is really cool because I wouldn't even say every day, every hour they come to me with a different problem of something that they can simulate. And it's really cool because it's something immersive that they can work on a daily basis and really have tangible evidence of how to put the theory into practice of the things that they're learning in their class. I'll talk a little bit about the current undergraduate student experience arc. Some of you may have seen this slide before. I've updated it with kind of the latest numbers, but in terms of the impact that we've made, and I say the word we, it's a team effort, but in terms of teaching to undergraduate students, in first year, there's about 200 students that get exposure to discovery through a course that I've taught in the past. It's a concepts course in mechanical engineering. There's a number of second year courses in solid mechanics, in mechanical mechatronics, biomed, and systems design. So that's about 400 students that also get exposure to discovery. There's some machine design courses and some lab activities that we do in both discovery and flagship. So they kind of start to transition once they reach the limitation of some of the physics that they want to implement or some of the numerical solving techniques they want to implement in third year. And then in fourth year, that's what Chris mentioned is we kind of the crown jewel of the student experience is that fourth year design symposium. I'll show you a picture of it eventually, but there's about 200 students that go through that. And there's an analysis competition where effectively the students apply to say we've done some form of engineering simulation using a software package. Almost always it's Ansys. And here are the numbers from the very inception where we started. So you can kind of see in 2017, we had our first competition, and the numbers kind of remained stable up until COVID, where they kind of spiked because a lot of the stuff was done obviously remotely. So simulations became much more attractive from that perspective. And then post COVID, I would say that the numbers dipped a little bit in terms of the amount of student engagement with this competition. But the numbers are a little misleading here because we actually raised the bar quite a bit in terms of the quality standard of what would qualify to even enter. So we get tons of proposals for this, and just to enter the competition, there's some bar that we set in terms of simulation quality. So these are full-fledged simulations that are case study worthy, in my opinion, in 2022 onward. 2025, the number isn't quite showing up there, but it's actually 50 students here. Apologies for that. So we're on an upward trajectory, and the benefit, or I guess maybe the reasoning behind that is the fact that they're getting exposure to it earlier in their undergrad, and it's not an afterthought by the time they get to fourth year. They're like, oh, this would be a nice to have thing. It's ingrained in their ecosystem of engineering tools already because they've had exposure to it. So there's somewhat of a networking effect exposing them to it early. And then they obviously see that in the end of their culmination of their undergraduate. We've done a number of technical development modules as well, which are very specific case study based exposure to maybe a biomedical engineering example or a thermodynamic example or something like that. And then, like I said, I've taught a graduate course to approximately 50 students a term for the better part of the past decade, which was really cool. I will touch on one really interesting example from the fourth year design project in the next slide. This is a case study that we're actually working on with Caitlin and a few co-op students right now called Schlieren Imaging. This was a fourth year design project that the students wanted to effectively couple with an Ansys simulation. So what you're seeing on the left is an experimental visualization of the flow behavior of a hot coffee mug. I don't have a coffee here. I actually have an espresso cup, but if I had a hot coffee mug, this is what the airflow on top of it would look like using a digital image correlation technique to actually visualize the airflow. And here is a simulation model in Discovery on the right that we use to effectively look at and compare and contrast the steady state behavior of the situation. So this was a really interesting project that the students visualized. Here's a candle of the same thing, and the simulation models on the right. They also looked at a Dyson hair dryer. So this is a pretty relatable, let's say, artifact for a lot of students. And it has a really interesting behavior where it has this dual jetting that the simulation was actually able to capture. So that's one thing that fell out of a fourth year design project. That was a really cool case study that we're actually working on finishing right now with Caitlin and Janos. Another one came out of I think this was a third year course in fluid mechanics, and a student athlete that was playing on a floorball varsity team, and they wanted to understand the effect of spin on a floorball. So here's a simulation model, and with the Ideas Clinic, we actually created a mini wind tunnel that we can then use to visualize the flow separation around this floorball. So hopefully these are relatable examples. I'm trying to pick ones that are not super technical because it's more accessible to kind of a wider audience. So this is something that was pretty cool, and there's some research that was published on this. So pretty interesting and engaging example because the students can then pick it up and throw it around the lecture hall when we're doing the example, and they can kind of feel engaged with the content. As far as the specifics of this master's degree in simulation structure, it's a 4-course model that takes 12 months. So a traditional course credit is 13 weeks, 3 hours per week at the University of Waterloo. So there's 3 special topics courses and 1 reading course, this is just a codifying of the language for kind of the Senate at the university. But effectively, what it does is it couples 3 fundamental kind of theory simulation courses with a practical simulation course where the students do and partner with a faculty advisor where they kind of do a really in-depth simulation. And these are repeatable in nature. It's done in hybrid studio format for Masters of Engineering students. And it could be industry learners attending as well in online capacity. And this really the only credential that they need is an undergraduate degree in engineering. So it's very cross-disciplinary in that respect, and it can be pursued as a standalone credential or a part of a larger degree. So here is kind of what the assessment looks like. I've taught this particular course, so one of these courses is about 30 to 40 people in general, and this is kind of the course schedule of what it would look like. The logistics of it, I don't think are terribly relevant for this audience, but what I want to really emphasize on the next slide is the pedagogical approach. So this triangle, which I'll revisit quite a bit, is coupling theory, which I'll use Bernoulli's equation as a very traditional thing that we need to teach to undergraduate students regarding the relationship between pressure and velocity in a moving fluid. And here is a simulation case study that we've made and published. It's actually on the Ansys website right now on a Venturi tube of the same style of physics model. So the theory and the simulation are there. This is where the University of Madrid's program kind of stops, in my opinion. So they have these 2 things and they're done really well, but effectively validating the simulation and calibrating, or let's say correlating it to a physical experiment is where all of the case studies that we've done thus far and plan to do in the future are, in my opinion, enhanced. So we have a simple experiment. There's a 3D printed Venturi tube, some simple measuring devices that the students can use and then gain their own data to go and improve the correlation factor or the accuracy of their model. They can understand the boundary conditions. They can manipulate them in a way that you can't do in a physical experiment in the simulation model. And you can see the lines that I've drawn in here often you might think it's a straight path to go from theory to experiment to then simulation, but you can see how it's this meandering pathway because there's an iterative technique that the students will then appreciate, and this is the way that real design is done in industry. So this is a really useful thing that the students would do. And you might say, well, this is interesting. I think it makes sense, but how do we really know truly it makes sense? You don't have to take my word for it. We've published a number of papers in pedagogical journals regarding this, and it's not a new kind of formulation of this pedagogical approach, but I presented at Canadian and American Engineering Association conferences regarding this. Dipankar and Caitlin and Janosch and Chris and Samara have been co-authors on a lot of this. I presented at NAMES a few years ago, the North American Materials Education Symposium, which was a great experience. I've also presented this to Professional Engineers Ontario, and it's pretty much a resounding supportive kind of mentality. I think it's intuitive that this three-tiered approach is effective in solidifying students' involvement. I've actually did a webinar. So thanks to, I think Bridget was the one that arranged this, and Caitlin, but I did a webinar that's on Ansys' webpage regarding this, and it's called Transforming Engineering Education with Coupled Simulations and Experiments. So we're actually publishing a paper in ASE, I think, this coming July. So that's something that I'm looking forward to. As far as the case studies that we worked on in the past, I'll kind of do some flashing of the highlights of them, but they're posted to the educational resources page on Ansys' webpage. But we've done one on a 3D printed heat exchanger. That's a really cool exercise where the students can actually print a heat exchanger using a interesting filament that's doped with copper to give it some heat transfer properties. And this is something that students would never have a chance to really visually and spatially kind of visualize the areas that are in contact with one another in a simple crossflow heat exchanger. So that was one that was really cool. We actually worked with a YouTuber on the next one, which was a charcoal barbecue. They wanted to understand more quantitatively how much the behavior of the barbecue changes when you add different elements to it, like a pizza stone or a slow roller, or these devices that effectively make it change the internal airflow cavities. So you can kind of see here, we actually took a barbecue and we put charcoal in it and made effectively a fire inside of it. And then we instrumented it and we created a digital twin of the environment in a simulation model. And this is also on the educational resources on Ansys webpage, which I think is a really different type of case study. There's nothing really to compare to from that perspective. Here's some more. We did one on the Venturi tube that I talked about. Tuning fork, which is really cool. The students all get a little kit with tuning forks in them, and they get to learn about acoustics and vibrations in the frequency domain. This is a really good introductory exercise to teach that. A walking crutch, which we partnered with biomedical engineering on this to understand the viscoplastic behavior of some of the rubber components in the contact areas of the knee pad and the floor kind of pad on a walking crutch. Here's some more. I alluded to the Schlieren imaging one, which we're still working on. And then there's a shoulder joint that we're working on to understand in a shoulder joint replacement, what is the pressure distribution in these kind of biocompatible materials that we're looking at. So this, I think, is the humerus. And then there's a femoral cup and some other aspects of this that allow it to be a replacement joint. And then more traditional mechanical style examples. So you'll see from the industry partners at the end of the presentation that have been engaged with us. This is one that they kind of propose regarding spur gear analysis. So a very traditional mechanical example. I'll skip through the next slides here and I'll keep looking at the individual streams. So we've worked on developing all of these case studies as individual components of this larger diploma. The structural analysis stream is here, and you can see some examples of things that we've looked at. So there's even really simple examples like a linear spring and how it behaves under load. So, and the students all get a spring and they can play around with it and do their own experiment. And just to understand at a very basic level linear elasticity and how you can get nonlinear effects from geometry, and then how you can take that nonlinear effect and kind of amplify it in this case here where you're inserting this little pipe into a clip. And then even taking it further to use more of the flagship software like LS Dyna in a crash analysis. So you can see that the case studies start from very beginner level to really advanced. On the fluid mechanics side, there's that floorball experiment. We have a lot on external aero. This one was from a student team to do a PID control algorithm on an air brake for a rocket, actually. So they wanted to understand at different positions of these small little slats, how would it affect the drag that was induced on the front of the aircraft there. And you can see some of the other ones that we've already looked at here. Almost there, electromagnetics and RF. So there's a few that we've done on beam forming arrays regarding simple 5G antennas. We've also done some on wireless charging coils as well as inductive motors on the low frequency side, but pretty much exclusively are using HFSS for this within Discovery, which honestly is a more recent adoption of this physics, and we're excited to kind of produce more on this front and do more case studies regarding this. So part of the ask at the end of this is for resources to effectively develop these further. On the robotics control and automation, there's a lot that we've done on dynamic system control regarding self-driving vehicles and things like that. And this is part of the overall automation and control pathway in the graduate diploma. But often this is a difficult thing to couple with a physical experiment. But here you can see we have a platform that we call a turtle bot that allows us to do motion control and a localization of a robotic platform that's moving around. So here's one on a quarter car model. So it's effectively a spring mass damper system. So there's some pretty cool case studies that we've done on that front. Regarding digital twin and simulation driven design, I won't belabor you with all the details here, but things like topology optimization, generative design, those are where this fits into. We did one on an IKEA chair, which is a really cool case study. In my opinion, we actually published a pedagogical article on it. And this is something that the students sit on the chair and it's visibly deforming. And it's the most popular chair, at least in North America, that's in student dorms. So it was one thing that we did actually during COVID as a case study that was really interesting. The second last stream here is multi-physics. And then Caitlin just said, I think I own this chair. Yes, I have one in the other room here. Yep. As far as multi-physics goes, we are working on a fluid structure interaction model for a aortic heart valve here. So effectively, when the heart pumps, the valve and the artery changes its dimension or its diameter, and that changes the way the fluid flows through it. So the arteries might dilate and expand. So that's something that's really cool. As far as acoustics go, we have a number of case studies on that we've worked on. And really, we want to build upon taking these assets and moving them to a full-blown case study that we can publish on the Ansys website. So part of it, of the ask is to kind of move forward on that. The final one is additive manufacturing and lifecycle analysis. So doing topology optimization specific for additive components is something that Janos has been an amazing resource on, because that's his graduate competency, I would say, in research. So that was really cool. As far as modeling the additive process, that's something that we've looked at in the past, as well as recycling the additive material afterwards and looking at in Granta or EduPack kind of the life cycle analysis of all of the different materials that you might use in a multi-material component. So that was pretty cool. So hopefully I didn't scare you away with all of that content. That's just a snapshot of it. It's a lot. I would say it's a lot more than that. I tried to pick the more interesting topics to look at, or engaging ones and familiar ones. But as far as the proposed engagement goes with Ansys for moving into the future, I know I think it started in 2021. There was a 5-year supporting agreement that Ansys had with Waterloo. We'd really like to scale that up in the future and maybe deploy it in a much more condensed format, because we'd like to run this particular Masters of Engineering diploma with exclusive software kind of ecosystem. So all the examples will be in Ansys for this MEng curriculum. So that's one key differentiating factor from the previous kind of agreement that was there. But it's an enhancement. There's a ton of value on Ansys's front that these industry-ready learners are going to get exposure to the software and then go to obviously corporations and hopefully convince them to migrate to the ecosystem if they're not there already. Like we said before, kind of intrinsic in all of this is the experimentally validated flagship case studies. I'm calling them flagship because it's just not a simulation and some theory. There's actual experimentation and simple, easily deployable experimentation that can be scalably kind of done at other institutions as well. And these co-developed case studies and educational resources that Caitlin referred to. So these are the kind of benefits to Ansys, so to speak. A ton of academic publications and recognition at international conferences. So you can see almost all of the content that I've shown here was within Discovery. So that's a huge thing. It's a gateway to the flagship software. In my opinion, it's the easiest entry for students to learn. The capstone design competition. So we still want to continue on with that. There was some monetary award there, and there's some co-op students that obviously need financial assistance in order to participate in these types of things. So part of the financial contribution that we're asking from Ansys is regarding that, as well as doing more webinars in the future. There's a ton of value in that for us and Ansys as well. And then further integration into the undergraduate curriculum. I think one of the huge benefits of my involvement over the past 5 years with this, in my opinion, is we've over-delivered on our promise in terms of exposure to the undergraduate students. I think it was on the order of 50 to 100 students that we were planning to kind of expose to Ansys products. It's been well over 1,000, in my opinion, per year. So that's really cool, in my opinion, and it's a great target to kind of push towards in the future. So as far as industrial support goes, we have some commitments already from a number of different manufacturers. SKF is a bearing manufacturer that we're working with. A pretty big flagship sponsor is Toyota Manufacturing. That's actually very local here to University of Waterloo. So here's an example of an Ansys case study that we're doing on external aerodynamics on one of the vehicles they produce. The Professional Engineers of Ontario, like I said, for that continuous professional development track of student that might be attracted to this would be one thing that we could leverage there. Ontario Drive and Gear, they do gear train and require analysis, and we've done a number of different activities regarding that. So the strategic value, in my opinion, is there. We want to build upon it, and we want to make Ansys kind of the flagship partner for this Masters of Engineering degree, on top of what we already were doing in the past with the design activities and the case studies and the webinars and the fourth year design symposium stuff. So hopefully I didn't scare everyone away with too much talking, but now let's kind of break for some questions, and hopefully we can open the discussion to see how we can realize this partnership in the future.
Andrew, if I might go first. So there are 5 or 6 different streams in the MEng program, and each one of them has a 4-course format, correct? If I understood correctly.
So it's interdisciplinary in the sense that we group one course with 3 design activities. Sorry, that might have been a little bit unclear here. Let me go back. So one course is effectively 3 design activities that might be 3 different case studies. So they'll probably be grouped together as electromagnetics and RF, but sometimes we do, like multi-physics is inherently grouping 2 things together. So depending on each of these 4 courses are kind of specializations for students that are coming from electrical and computer engineering, mechanical or civil, things like that.
Okay. And the reading course, is that that's more sort of assigned readings that the students have to do in conjunction with their labs, for example?
It's a little bit of a misnomer because this is the way that we can get it kind of accepted at the Senate level at the university. The reading course is effectively allowing us to bin a 4-month-long simulation project for the students. So it's a simulation project that this is actually something that the university was extremely interested in. There's a lot of faculty advisors that don't have the scope of work for a master's student, a complete master's student, to do a 2-year project. but they have tons of projects that are 4 months long. This would fit into that exact category.
Okay. And the second question is, has the program been rolled out, or is there, is there ongoing enrollment in these courses, or is it proposed for the future? I didn't quite, maybe I wasn't listening hard enough, Andrew.
It's a great question. We've taught these courses individually in the past, but we haven't actually graduated the first student from this program. It's still in the process of approval, but the entire faculty is supportive of it, and getting industry support from Ansys financially and in terms of intellectual contributions as well is going to be helpful in that process, I think.
Okay, so in terms of at least a target or aspirational launch date in terms of getting the first cohort of students in there,
this fall.
What are you thinking?
This fall,
okay.
Yep.
Okay, yeah, okay, got it. All right.
I'm glad you asked that, Dipankar, because some of my question was on that last question you asked as well. I guess I need to better understand like what level of financial contribution you all are asking for, because that obviously makes a big difference in understanding capabilities on our side. I think what you walked us through was excellent in terms of everything you guys have been able to put together, and it's great to see how much technical collaboration our team has already been able to provide you as support. And I think we can talk about details, but I think from that side of it, certainly that's why our academic team is in place, and we would be happy to continue to work side by side with you on the development of curriculum and relevant examples, and provide exposure to what is put together on our website and things like that. I'm just there's been a lot of comparison to the e-masters program that we have with the Technical University of Madrid, and I think it's important to note that we never provided them funding to get that started. So I just want to piece together exactly and understand how much funding you're looking for and what exactly you're planning to use that for, I guess, because that's not typically what we would do.
Got it. We would like to at least continue at the level that we had in the past. I think in terms of the agreement that was in the past, there's a lot of extra value in terms of the assets that we've developed and will continue to develop. So if we can increase that contribution, that would be amazing. This particular program, in order to kind of get approval and traction, if it's externally supported for 2 years, in the beginning, and that might be a contribution of 50 to 75,000 Canadian dollars per year, something in that range. It would be, I would say, much more successful. The probability of success and widespread adoption would be much higher. I maybe Chris or Simar, if you want to add to that, feel free.
Chris, I think you're muted.
Yeah, sorry. The one thing I'll say, Susan, just for context, for the last 10 years, the agreement has been 25,000 Canadian a year from Ansys. So for us, at least, our sort of costs are entirely on salary. We have Andrew working on this, of course, but kind of in the background, behind the scenes, working on all of these experimental setups, simulations, have been teams of co-ops. And so really it's that co-op salary that we're looking to cover. And yeah, so we typically have kind of 2 co-op students every term that are working on these FEA projects, helping Andrew with the workshops, kind of getting all the teaching materials ready, that sort of thing.
So Dipankar, and we can talk about this offline if needed, but can you help me understand, I haven't seen any line items for that budget that came to me, so I'm assuming that was pulling from some other budget.
Yeah, and I'll give you an insight. So I kind of dipped into the meager pockets I had in the office of the CTO and had a little bit of matching funding internally from the DBU, right?
Okay.
So as Chris mentioned, that was in the tune of 25K Canadian per year overall.
Okay.
And we kind of split the cost. But, I think you asked the more important question is in the go forward, what are the kind of our collective thinking in terms of expectations. So now there's a reason, Andrew, Chris, and Simar, the world had kind of changed on us quite a bit, right, this last year. And so in a way, we almost, Susan and I, we're kind of starting from scratch again in terms of how generally the stakeholders and the community think about these things. So, but it's good to get these questions out up front. I think I'll just repeat the tone that was there in Susan's point here, that I think you can pretty much take for granted all the in-kind investments that that you're hoping for from the Ansys Synopsys side. That and more is to be expected. I think there is definite interest, Andrew, from the local office in Waterloo, from the technical community that they want to do more for Waterloo. In fact, this morning I fielded a call from, Steve Royce, correct?
Yep.
Steve Royce and Dan Williams as two senior R&D heads in that office. Steve is, of course, a Waterloo grad, but there are quite a few others there in that office that are hoping to do more for UW. So in terms of mentoring, maybe helping support coursework and all of that. So anyway, to cut a long story short, the software and the resources from the point of view of actually people time, I think is gladly distributed and given, and possibly more, right? It's the actual hardcore dollars that are getting increasingly difficult to get. So I don't think Susan said no right away, but I think we are going to have to go and get a little creative internally as to how we solicit that funding, right? So would it be fair to say that you're hoping for at least a baseline continuation of what it has been so far, and potentially thinking about increasing that if we could? Is that the message that?
I think that's true, and I think if it's hard to get commitment for 5 years. I think the way that agreements are done, ideally, that would be amazing if we can continue at a higher level for 5 years. But I think it would be in our favor if we can compress that entire amount into a larger contribution for a smaller duration, if that makes sense.
Yeah. Okay. We will definitely talk offline. We've also been a little bit caught in between because our fiscal year changed as well when we rolled from Ansys into Synopsys. So their fiscal year has already begun in 26, right? So it's a little offset by 1 quarter. So anyway, Simar, did I interrupt you about the comments?
Yeah, I just wanted to give you the Ideas Clinic perspective, right? So when this agreement was formed, we had a NSERC chair from the government of Canada, from NSERC, which was subsidizing a lot of the activities for us, and that's why we were able to do a lot of that thing. That chair program has finished also for us.
Yeah.
So right now, for the last year or 2 years, basically, to run these FEA activities, we were dipping into our foundation money, which is becoming more and more difficult to tap into. We are also going through the same financial considerations in the university. So, at some point, we'll have to look at the amount so I think we probably would need to be around 50K for us to be able to justify to my dean, because that's where our other donors are coming in. Other donors come in between 50 to 100K, and then our advancement team has to justify whether, how much time we are spending in Ideas Clinic and how much of it is paid for and how much we are dipping into the foundation to pay for it, right? So, yes, sorry, go ahead, Susan.
Oh, I was just going to say, I think you have our commitment to Punker and I's commitment to, go away from this meeting and see what creative things we can come up with. But I also am a firm believer in being very open and transparent. And, I think a good partnership, you have to, be that way, right?
Yeah.
we are in a situation where we're going through a huge integration right now, and there is still very much a commitment to academic at large, but it's not the easiest time for us to be looking for extra dollars that aren't budgeted either for a variety of reasons. We do have a formal funded curriculum program, which is a little bit different than what we're talking about here, but I'm putting a link in the chat that you guys could maybe take time after this call to go through. This is, dollars that we do have budgeted where we actively grant money to universities for the development of curriculum, which would be in part in line with some of the things you guys described for new courses. So that could potentially be a path for some of the dollars. But I also want to say, generally speaking, we work with close to 3,000 universities across 86 countries, and our whole program exists to really facilitate and help, from a technical perspective, get universities teaching, with Ansys and curriculum. It is not really realistic for us to invest dollars for every university to get programs off the ground. So that just generally is not really our strategy. So, while I think this is an amazing program, and we will, I think our relationship with you is important enough that we should see if we can be creative. I just want you to understand that generally speaking, our partnership comes from the technical support of being able to teach with our products, not necessarily funding the program per se.
Yeah, understood.
Yeah. And of course, the software contribution side of it too. So, Simar, I know you were comparing us a little bit to some of your other donors. So it's classically, as you know, in our relationships, always been a combination of that little amount of cash contribution, time and resources, and the software suites as well.
Yeah, no, I totally agree with that. And I'm just giving you the reality of our university right now, right? Like being able to sell it. Our typical donations are between 50 to 100K, with a lot less work being done in the Ideas Clinic for those donations. So I have to be able to justify to my dean also, right, that this is an activity worth pursuing for us. And I'm very supportive of this activity. I think there is a lot of opportunity for us in the future.
Just a question. I hope this is not distracting from the core topic, but is there any opportunity to seek, third-party, at least sort of matching funding or reimbursement?
We are trying that. We are trying that from the that's where I think Toyota is one of those ones we are working with. We have meeting with a few other companies from the experimental side. So we're trying to get matching fundings from other things to create this FEA kind of design simulation and then testing platform for us. So
I think that it sort of went implicit, I guess, but the GDip program in itself would have funds associated with it, right? Because folks are enrolling in that. So I think moving towards that graduate diploma is also trying to move towards financial sustainability for all of this. It's just the kind of time between today and when we actually get to that diploma being offered.
Yeah. Okay. Can you, Andrew, share these slides with us? Is that possible? As we, Susan, myself, Caitlin, others mull over the possibilities.
Sure. I don't have an issue with that.
And so I was just quickly looking at this funded curriculum. So we just write proposals for you for this.
Yeah, it wouldn't. So it's basically an open call for proposals for strategic curricula. And it's not going to get you to your $50,000. We would cap out at $25,000 per university for that, but certainly it could be a path to get, it was mentioned by somebody that, a bulk of what the money is used for is, hire co-ops that basically help develop the exercises and curriculum. That's what the funded curriculum program really is in place for, is exactly that. We do that in a scalable way by inviting proposals from universities all around the world. So, I do think that could be a path to get some funding for this.
Sure.
And Susan, could you remind me where we are in the cycle in terms of taking call for proposals on all of that?
Yeah, the next deadline is March 27th.
March 27th. So, in principle, Andrew and Chris, I mean, especially given the fact that you've, goes without saying, a lot of track record and material to put together, that's an avenue definitely worth pursuing. And we can talk a little bit offline about that.
And I'm assuming it's 25 USD or 25 CAD?
Yes, I was about to say it's US dollars. That's a good
It's US
news.
dollars, right? Yeah, I mean, that's about 37 CAD for us.
Yeah, Bridget is the organizer for this. I think I talked to her in ASCE about it last year. She was recommending this as well. Okay.
Yeah.
Cool.
Yeah. So Bridget is part of Susan's team, and the budget is Susan's too. So I should be a bit careful about how freely I cast about statements about that program.
But I mean, in many ways, I mean, I do think there's alignment here. Like I said, the concern is it's not maybe at the level you guys need to be, but I do think it's, a at least in part solution. So.
Yeah, definitely. And the other thing, I think Susan might mention this, I should reiterate, the spirit of that program is also, not a continuation year after year after year program. It's sort of meant to be seed funding to help kick off a new program. We could potentially position the MEng program as a new one, right? Because internally in the justifications, we'd be competing against other proposals that are kind of quote unquote brand new programs. So we'd position this MEng program as a new program, not a continuation. Did I say that right, Susan? I don't know if that was appropriate. Okay.
At minimum, it should be generally it's for new courses, yes. But then in the bigger proposals, it's typically more build out either a new program or maybe, a proposal that spans multiple departments at a university that are going to use Ansys,
Yeah. And certainly that characteristic is there because this is an interdisciplinary program.
Yeah.
Okay.
I mean, I was just going through, it says that proposals that include photonics would be prioritized. So should we focus on that side or even the...
So each call that we have, we tend to have a theme for that call. Part of one of the benefits to us of doing this funded curriculum strategy in general is the education resources that, you guys are familiar with as, I believe Caitlin had put a few in the link that you guys worked on. Basically, we're looking to fill gaps, so we give funding to universities to help them get a new course developed or new program developed, but then in turn, we can use a part of the resources that are the curriculum that's developed for a resource. And then ultimately that helps us drive adoption of Ansys at other universities. So this theme of the proposal is photonics and optics. So yes, I mean, those will be prioritized, but it does not have to be that. So we will accept proposals in any area. So I mean, I would just say how relevant it is for what you're trying to do. I wouldn't abandon what you're trying to do here. If you already have a thought out plan, I think it's fine to submit a proposal for that. But if it naturally fits, then that would be helpful and get you extra points, so to speak, if you can include that. Yeah.
Sure. Okay. Sounds good.
Yeah.
Chris, you have any questions? Or...
No, I don't think so. Yeah.
Andrew?
I'm good. I think that was a great meeting.
Thank you.
Yeah, it was definitely helpful for me, I can say so.
Yeah. And we really appreciate the many years of partnership, and particularly, if I might say, in recent years, we collectively managed to up the game totally, from a few years of, less intensive work, and the partnership has been very intensive in past years. Really appreciate that.
Yeah, no, likewise. This has been, I think, the better part of a decade that we've been working with you folks. So thanks for all your past support.
Yeah. Thank you.
Awesome. Well, Dipankar and I will see what we can come up with and then reach back out when we've made any progress. And then in the meantime, yeah, I would continue to review that funded curriculum. And if you guys have questions, feel free to reach out to Bridget and you can CC me so I can give her context if needed. So you're not starting back over at, the ground level.
Okay.
Sounds good.
All right,
Thanks,
guys.
Susan.
Thanks.
everybody.
Have a good day.
You too.
Bye.
Bye, y'all.
Bye.